The following clip you are about to watch will deal with the shear resistance. We will discuss what shear resistance is and why we use bent-up bars to resist shear. Where do we use the bent-up bars as well as the effectiveness of using these bars.
What is shear reinforcing? Shear reinforcement is the reinforcement that is able to resist shear or diagonal stresses. Bent-up bars ensure that the structure resists the shear that is created at the corners of the structure, because cement can bear compression but it cannot bear tension. Therefore, reinforcement is needed. Bent-up bar causes shear resistance. This is the force required to pull the pressure-sensitive material parallel to the surface to which it is affixed. This is a picture of bent-up bars. This is what it looked like, and this, you can see this is the shape of a V. You can see the side corners of the bars are bent up, or truss bar they call it, with a hook on each side that will take the forces of the side corners of the structure. At the bottom of the bent-up bar, you have the support that will keep the middle up straight, in which the middle won't have shear. This is a good example of what a bent-up bar is. What is the purpose of bent-up bars? There are many factors that allow the enhancement of the developments of both the tensile and the shear reinforcement. Bent-up bars just mainly resist tensile and shear strength. The most commonly used to increase the punching shear strength of flat slabs. This is basically when you have a column on a flat slab, the force will basically be distributed through a 45-degree angle throughout the flat slab, and it will basically carry the weight of the slab throughout. Bent-up bars have been abandoned and replaced by double-head stud stirrups and shear steel heads because of the ease of construction.
Bent-up bars are normally for fixed-end beams with positive sagging moments at the midspan and negative hogging moments at the support. Bottom steel is required at the midspan and top steel resists negative moments at the supports. A bent-up bar is provided on the top at the support, as bottom steel is not normally required at the supports. For shear resistance, bent-up bars are particularly suitable for continuous beams in which negative moment at the intermediate support need reinforcement at the top of the beam. The angle of the concrete strut should be calculated to determine where the shear reinforcement is required. When the shear stress is greater than 3.27 Newton per millimeter squared, then there is a maximum permitted shear capacity, which depends on the concrete strength.
The strength and deformation capacities of slabs with bent-up bars compared to these ones without bent-up bars can be increased significantly. The flexible reinforcement can be decreased without losing punching strength, which leads to even larger increase of deformation capacity. The proper considerations of detailing rules are essential to achieving an increase in strength and deformation capacity. For example, a failure at the outer perimeter that would limit the strength and deformation capacity can be prevented by using shifted bars or a flatter inclined angle of the bent-up bars. In conclusion, when the bent-up reinforcement has been correctly arranged, it can contribute to the shear strength and is normally calculated by the means of the equilibrium equation. Figure 1 shows a reinforcement beam and it's bent up in the longitudinal bars.